So while they're loading it up, many of you in the room know me, Rick Relyea, Director of the Jefferson Project. About half of you were at the Finger Lakes Institute meeting last week where I gave a long, 40-minute description of the Jefferson Project. For those of you who weren't there, I brought, this is our most recent annual report, and I promised to only talk for about 2 minutes and then yield the rest of the time to Mike Kelly, who's led our Skaneateles work. So I'd like to pass those. If you've already got one, just pass it along. A little bit of history. 2013, IBM, Rensselaer Polytechnic Institute, and the Fund for Lake George got together, inspired by 30 years of data on Lake George, to say, let's study lakes in a really advanced technological way, in ways that really no one in the world has done before. We always use traditional monitoring, but we've now set up what we call a smart sensor network. And some of you know a lot about this. Basically, intelligent suite of sensors all around the lake, weather stations, tributary stations, vertical profilers, current profilers measuring our current flows. And to put all that together in a really novel way with new intelligence, new computer boards run by Raspberry Pis, to allow us to see an awful lot about the lake. A series of experiments to help us understand nutrient additions, invasive species, global warming, all of those human factors. And then to model a lake like no one in the world has ever done before. So high resolution modeling of the weather, how that drives runoff, how that collectively drives circulation, and how that drives the food web. Have them coupled, those first three, the weather, the runoff, and the lake circulation. They currently run for Lake George every day, giving us a 36-hour forecast of what's going to happen. The highest resolution weather forecasting in the world, which is about 1/3 of a kilometer resolution, and we need that because we're surrounded by mountains. And to put all that together in a way to help us understand, and to Dave Matthews' point, what do all of these models tell us? Well, one of the things we're really striving for them to tell us is, first, let's get a mechanistic understanding of why we see things happening like harmful algal blooms, not just phenomenologically, but what's the underpinning of those occurrences, and Mike will tell us more about that. And then moving forward, as you just heard about the remote sensing, thinking about the future. And one of the things that we're pushing on is what we call a scenario engine, which says, not only if we understand the underlying mechanisms, do we understand why harmful algal blooms happen in Skaneateles Lake, for example, but take those models and then say, under different potential scenarios of policy, if you were to drop nutrients 10%, 20%, if you were to reduce nutrients due to agriculture, due to wastewater treatment plants, what would the outcome be based on these models? That helps educate policymakers, it helps educate the public, etc. But the underlying part of this is we have to have high quality, high frequency data, and you heard Rich Abbott talk about the very dynamic nature of these harmful algal blooms. They show up and they disappear sometimes really quickly. I think we would argue you need very dynamic data to help you understand that. We used to think every couple of weeks was enough. We clearly need higher resolution data than that. And I'll let Mike Kelly talk more about that. We came to Skaneateles Lake. We were asked by the governor's office in 2018 to come out. We scrambled in about 3 weeks, got out here, brought our vertical profilers and the team out. And in 4 months, again, it was all at our cost. We came out to Skaneateles Lake, did, I think, some really interesting work, and I'll leave it to Mike to tell you all about it.